Well, you mentioned I have been before. I can't remember whether it's 2 years or something like that. And I brought boxes of things, and they were to do with noise cancelling. So I had all sorts of gadgets to show you what audio improvements could be made to our listening on the air. This is a different approach, and I'm sure it's an approach that some of you have tried. You know, starting with the problem of the noise getting to the antenna. And so, you know, basically I'm going to show you with lots of video and audio examples how I've achieved my aims, as it were, of a noise-free signal, to some extent anyway. We're going to have a quiz part way through, chaps, so if you wouldn't mind having a piece of paper and pencil handy, just the warning, I'll give you time to find something to just do a simple quiz. It's got 7 questions, so it's like a party quiz, and I'm sure you'll enjoy the interaction that we have just doing that together. There are probably some here tonight who would respond positively to the question, have you been influenced to start a project, you know, buy a radio or an accessory or design a circuit as a result of reading an article in Radcom or Practical Wireless or some other periodical. And this was the case in the last BWC meeting about PCB manufacture, where a recent Radcom article was referenced during the presentation. And it's easy and tempting to be influenced into purchase after reading a review, because it will be the solution to all your radio related problems and be an enhancement for your station, just what you've been looking for. And this is exactly how I committed to this purchase, the antenna build featured in tonight's talk. Now, I asked myself, has it been worth it? And could anyone else benefit from the product and my experience with it? After all, it's only a piece of wire, isn't it? I also have to say that the project should be seen as flexible and experimental and can be developed to suit one's own choice of frequency bands, the environment and local RF conditions. Nigel, can you tell me what you see on your screen?
I can see the Aziloop with Mark M0UFC, a Aziloop, and the front of the what looks like a control box.
Okay, well done. Thank you. That's exactly what I wanted.
Is that the first question I've got right?
That's a good answer, yes. So you can tick that one off.
Thank you very much.
You can have an extra point.
Thank you.
So what do you see now, Nigel?
I see the Radcom article.
Great. So the slides are working great. Thank you very much.
Is that another point?
Yes, that's 2 points.
Thank you very much.
I'm very grateful to Evan for going through some of the points of the presentation, because I've tried to do this presentation on Google Meet. Actually, I was doing it live at Bolton Wireless Club last week. And it was fine in the room because all the audio and video was absolutely fine, but Google Meet just didn't handle the audio stream. So it was gobbledygook to most of them. So I said, well, you can download the presentation and do it locally on your own computer. So somebody actually did that. Anyway, this is the review in Radcom, May 2024, featured the Aziloop DF72. And the article was written by the well-respected propagation expert Steve G0KYA, who incidentally has given an online talk at BWC. And he's written a thoroughly researched book called Stealth Antennas, which I read and recorded for the blind members of the radio amateurs charity called the RAIBC. So when I saw the product pictures, its general dimensions and the performance comparisons, I concluded that this might be the answer to my reception problems, particularly on 160 and 80 metres. And to whet my appetite, in his review, Steve quotes the designer, who says that the design requirement was a multi-purpose antenna that could be remotely controlled and nothing else existed. And so the Aziloop was born. And he states that Azi is short for azimuth. Steve, further extolling the incomparable features, he says that the receive antenna is unique, being stepped azimuth technology to produce up to 72 unidirectional headings. And to be clear, he says, the whole antenna does not move. Rotation is achieved electronically, the whole antenna being controlled from a PC-based application. And commenting on the build, Steve says the enclosure includes integrated pole mounts, allowing installation to be quickly completed and easily with just a couple of cable ties and Jubilee clips. Everything is controlled through the coax. And commenting on his listening experience on LF and MF, he used phrases like, none stations, that stations were audible on my 132-foot long wire, and on 160 metres the loop was very effective at nulling signals if need be. And in conclusion, Steve says the benefit of having a receive-only antenna is often cited as the biggest improvement to making contacts on the low bands. The signal to noise is a key component in this, but also the arrival angle of the signals. However, you can't rotate a dipole to null or peak the signals, and this is where the Aziloop comes into its own. Can you see the questions there? What is it? Who developed it? Who is it for? What is supplied? What else is needed? How does it work? How is it built? How does it perform? Where can I get it and how much does it cost? Where do I get further information? So what is it? So the Aziloop is a dual mode multi-directional antenna system for a VLF to HF, and features unequalled, this is AI for instance, with features unequalled at this price point or possibly anywhere. So that's a challenge there, isn't it? So it uses a low impact small footprint comprising of a pair of orthogonal loops plus an earth, stepped azimuth technology for electronic rotation. The actual antenna remains stationary. You control everything with its intuitive Windows UI with selectable local, client or server mode. Dual antenna modes switch between loop mode and K9AY mode with a mouse wheel or buttons. More on this later. There are 108 antennas in one, 72 K9AY headings and 36 loop axes. You change with the mouse and the delay is 60 milliseconds. Switchable 18 dB preamp and a 4-step attenuator, 0 to 18 dB for up to 36 dB of level control. And there's a 7-pole pre-selection filter. In fact, there are 4 of them for the different bands to give your receiver an easy time. The variable K9AY load from 250 to 950 ohms in 50 ohm steps. 2 controller monitor ports for your own use, or allocate 1 to both PTT and muting. Headless remote control. No attached PC via the controller's built-in Ethernet server. OmniRig support for auto filter, PTT muting and rig sync. That's keeping rig A and rig B in step. So there's the panel that is displayed at its full length. You don't have to have that much on your screen. In fact, it on my laptop it takes up a very small portion of the screen. And so on the left you've got the compass with the 72-point headings, and you operate that with your mouse. There's a multitude of ways you can use the mouse. Can you see my mouse operating around the compass?
Yeah.
Yeah. So the center you can switch loop modes. If you move to the edge you can switch 90 degrees just by tapping the mouse. If you go even further you can switch to loop K9AY mode and various positions. Where's my map? There it is. Various positions along here you can adjust the compass, and if you use the scroll wheel you can do continuous movements as well. So next to that you've got the load on the antenna. You'll see that in the circuit diagram later on. The band pass filters there, so you can tap on one of the bars there to select the band you want, down to kilohertz up to 30 megahertz. The preamp is switched on and off up here, and you've got attenuation down to infinity, and infinity is quite a good idea because it enables you to silence receive completely if you're making comparisons. And then there's more to do with the features I mentioned at the end, like the remote and the rig sync and all that. You can set it to have priority in one mode or the other. You can have the cardioid response or the loop response, the figure of 8 response. More on that later as well, and various other little things about the way you operate, the different steps. And there's a minimum of 5 degree steps here, which I'm sure you'll find quite amazing when you hear it in a minute. So let's move on. Who developed it then? Well, it's Dave Evans, GW4GTE, and his QRZ page there gives very little information. But the website is actually a bit more helpful because it gives a sort of 5-year development for the project. His contact details. It's a small business, and it's got registered trademarks, so there are very few details about the actual RF and control circuitry. There's not even a block diagram, so some of it's a bit of a mystery. And but we do give him credit because he's published a freely available 120-page user guide, which is very well illustrated and easy to understand. So I've got a slide with some contact details at the end. Who's it for? Well, I'll just go back because I don't want you to read that. I just want to say something about newly licensed amateurs, and I'm guessing there aren't any here. Maybe there are here, but there comes a point when the thrill of making worldwide contacts becomes marred by requiring crash avoidance strategies, I call it, for propagation blackouts, intermittent bursts, or continuous noise, obliterating even the strongest signals. Some relief is found by many turning to digital modes whose narrow bandwidth mitigate against pollution. More experienced amateurs in towns and cities like us who suffer from RF pollution, such as solar panels and mains-induced interference, will have considered the advantages offered by installing a receive loop of some kind, especially on the lower bands. And the reasons are explained here, and I'm grateful for this little explanation from Jim Moritz, M0BMU, who's written in the Communication Handbook, Chapter 10. I think it's in the section on LF and MF, actually. Much has been said about the noise-reducing properties of receive loops. Electrically small loop antennas respond essentially to the magnetic field content of an electromagnetic wave, and so reject noise that exists as a local electric field. Unfortunately, most local noise sources in the LF-MF range involve common mode noise currents flowing through mains wiring, giving rise to magnetic fields which the loop will pick up. Using a loop inside or near a building almost always yields poor results. However, these fields rapidly decrease in strength as the antenna is moved away from the offending wiring. Often moving the receive antenna only a few meters results in substantial reduction in noise. Loop receiving antennas have a figure of 8 directional pattern which nulls at right angles to the plane of the loop and maximum sensitivity along the plane of the loop. The directional null of a loop is very effective in eliminating distant and local noise sources. So I've pinched some of his points there, and I'm going to illustrate them shortly. In fact, we'll take an example now. This is how effective a loop null can be, and this is figure of 8 pattern. So let's give it a go and see what you hear. So this is the DCF77, the Deutsche Chime signal from Germany. I'll say a little bit more in a moment. Yeah, okay, so this Deutsche Time signal from Germany, it's transmitted at a frequency of 77.5 kilohertz, and it's used to synchronize radio controlled clocks in Europe and other equipment requiring an accurate time source. I've no doubt you've had clocks and watches and things that pick up a time signal before, haven't you? But that's the one that perhaps is not our local one. So next, what I'm going to do, that's the figure of 8 pattern on the Aziloop. So here, this time we're using the other mode, which is the K9AY mode, which has a single directional cardioid pattern. And you can see in here that the complete nunning is achieved by the fine 5-degree resolution on the compass, which is adjusted by using the mouse. So there you saw me just at the end, yeah, just moving it 5 degrees either way just to see if it really was cancelling the noise. And it's amazing, isn't it, how that's really gone right down. In the next example of eliminating noise, I'm going to turn to a YouTube subscriber on the Aziloop channel who has some amazing clips of angular differentiation. Here he is struggling with solar charger noise.
It's, as you can see, a severe problem of interference on 80 metres. It's actually an MPPT solar regulator, and you can see it hunting around there. That's quite a lot of interference. Let's see if we can use Aziloop to get rid of it. Okay, I think it's roughly over here. Let me just try reversing it first. Okay, let's just tune around a bit. Okay, that's it's fighting back a bit. Check we're doing something useful. Let's see if we can adjust the load. Ah, right. Okay. So that looks like a good result. So what you might be stuck with is that, but if you're using Aziloop, what you could actually get is that.
Now I'm going to give you another example here. This is me, and I'm struggling to pick out a CW signal in the noise, but the changing directivity of the loop brings it out. Okay, keep your eye on the compass. Well, I'm sure you all picked out the CQ, did you?
Yep.
Good. Okay, that's on top band, as you can see on the readout there. Now, continuing Jim's observations there earlier about positioning, whilst I'm satisfied with the performance of my loop, which I use in the house, it's cross-country wireless loop actually, and it's connected to a Belka DX receiver, and it sits underneath the loop there with all the other cross-country wireless gadgets there, the BIOS T and the static protector, and beneath the Belka DX receiver, it's the powered amplifier. Being able to sit outside like this in the summer, in the warmer months, it's like a depressive cloud has been lifted and the heavens have been opened. I wonder if anybody else has experienced that. Using a loop antenna inside on your building almost always produces poor results. However, these fields rapidly decrease in the strength as the antenna is moved away from the offending wiring. Often moving the receive antenna by only a few meters results in a substantial reduction in noise. And last week one of our members quoted the actual figures for the the square root or whatever. It's phenomenal, the distance, the short distances that can achieve remarkably better results. So who is it for? Let's continue. Typical applications that we might use. Let's have a look at some of them. Let's go through. Nasty neighbours noise, atmospheric, electromagnetic noise reduction, direction finding, jamming mitigation, resolving co-channel stations, NDB listening and medium wave DXing, low angle DX listening, and SIGINT, that's the signal and challenge, the military aspect. Now let's think about nasty neighbour noise. Further to the earlier nulling clips, here is an example firstly of the hash from a long wire that I have compared secondly to the directivity of the Aziloop. Now my long wire, it goes over the house from tree at the front to a tree at the back, about 10 metres high, 30 metres long in all. It's a terminated loop. It's actually a terminated U, so it's got a resistor at the bottom end and a matching unit at the top end. And this guy talks about terminated antennas in a moment, doesn't he? Here is this example then. It's radio antenna Satelor Romanian station on 153 kilohertz, and it's on the long wire. That was the wrong way round. That was the Aziloop. This is the long wire. Okay, it's a little bit different, isn't it? Do you agree?
Yeah.
About the noise aspect there. Now, let's think about, that's an attenuated noise. What about atmospheric noise? And for that, let's return to our friend on YouTube. And this is him trying to deal with this atmospheric noise.
Quick demonstration of how you can avoid thunderstorm static. If you have a look at a map here, this is what's happening right now over Europe, so it's predominantly sort of easterly-ish. It's still daylight at the moment, and you can see on 80 meters there's quite a few crashes on there. If I switch Aziloop the other way, that gets down to more or less undetectable. So if we had someone there, they would be severely messed about with. There's a better one there perhaps, just appeared. And the other way. Clearly if it's someone further away with a lower angle, you're going to attenuate them as well to a certain extent. It just depends on the angle, but you can see the difference. If I go to loop mode, you see it's not helping an awful lot. You could actually go broadside in loop mode, and that certainly is an improvement, quite a bit of an improvement in fact, but you can still see some chatter there. But the best is when you go into K9 mode, beaming in the other direction. So one of the many advantages, you've got that at your fingertips.
Back on the slides now, I hope. So let's look at direction finding, and for interest in that, I use this clip. I was tuning on the medium wave band in the late afternoon on New Year's Day, and I came across a fairly strong station on 1377 kilohertz playing tracks of Asian music, announced by some English presenters. I was surprised to find that adjusting the compass in K9AY mode, that there was a complete null. And if you keep your eye on the S meter here, so the compass on the right will show you how I'm achieving the null, and the S meter will tell you the signal level reduction. So let's see how we go with this one.
The second hour, and if you just like saying Happy New Year to you from us.
Laker Radio Manchester. Chris Khan on Drive.
Listen, it's good to be with you on the first day of 2026. How privileged are we to spend this time together? A brand new year, a brand new start. It's a renewal for a tool. Hi, because that's what it's about, isn't it? It's a new year, and it's a moment for us to kind of think about last. For the next 12 months ahead. Now, on the show today, I'm asking you to think about like the first time that you've done anything today. We've had somebody who's worked for the first time on New Year's Day. I think I was working last year as well on New Year's Day. Today, where they first person you met, the first conversation that you had, the first, I don't know, person you saw, and you're like...
So the station identified itself as like a radio, and a Google search came up with a local broadcast from the offices in Strangeways, and I thought, no, it can't be coming from Strangeways. You know, Cheetham Hill, where the prison is. No, I haven't seen a transmitter there, a mast. The transmitter site was actually more difficult to find out. It turned to be Ashton Moss in Tameside, and a check on maps showed that from my home QTH, Shorten cum Hardy, the transmitter is indeed in a northeasterly direction as confirmed by the compass. For comparison purposes, I took my portable Eton outside near the Aziloop, and I swung it around to see if having the ferret rod aerial on medium wave, which should act as figure of 8 pattern, shouldn't it, whether it would reveal a similar response. So here, where are we with that? There it is. Yeah, so it does make a difference, and you can see that there is less sensitivity altogether compared to the Aziloop, but clearly an advantage there in using ferret rods, which we're obviously quite used to doing as amateurs who are brought up with superhet pocket radios. Now, common co-channel resolution, is a fairly common, and we have to cope with 2 station on adjacent frequencies. For co-channel interference, we say QRM, don't we? And I've come across that very often, especially in contests. So let's go back to our friend on YouTube who's put a knife to the problem. It's remarkable, isn't it? You get a music station there and a speech station in the opposite direction. Now, I've come across this co-channel problem whilst listening to NDBs in AM mode. These non-directional beacons, NDBs, are low-power radio transmitters used for propagation and direction finding. In spite of many closing down, many shortwave listeners enjoy chasing these NDBs. So they're ground-based radio transmitters. They emit signals in all directions. They provide bearing information for aircraft navigation, operating in low and medium frequency range, say 200 kilohertz to 500 kilohertz. NDBs allow pilots to determine their direction relative to the station using an automatic detection finder, and they are identified by an intermittent Morse code abbreviation. So here's an example. Okay, so more on NDBs in a moment. Did you catch the call sign of the beacon?
Yeah, it was Hawarden near Chester.
Okay, we're going to use that in the quiz later on, but just for the moment, I just want to tell you what's supplied with this kit. It's a small box. It arrives with 2 active units. The CIU, that's the common interface unit on the left for the shack next to your PC and or the radio, and the SMA connectors, receive sockets, they're on the back. But the LCU, the white loop controller, sits at the base of the antenna, and the circled terminal blocks are for the coax feed on the left, and the loop and the ground connections on the right. And also there's some other cables, USB cable and etc. There's no paperwork, and as I said, the extensive user guide is online. So what else is needed? Well, I use Windows 10, and I did need to install that font that there you see on the top line. My 7-meter fiberglass pole uses just 3 sections and stands about 3.5 meters high, and the K9 AY shape is illustrated there. but the Aziloop design does cut the dimensions in half. The Aziloop manual does recommend elevated radials, which I shall show you in a moment. And the coax feeder provides both RF and DC in one, and the performance is only limited by the DC resistance for very long lengths. It's wise to use a linear power supply or one of known good suppression. There is some protection within the circuitry for using a transmitter antenna nearby, but you should never connect it to or any other receive loop to the transceiver unless there is a separate receive antenna connector. They've tested many SDRs, and they've quoted as having tested the SDR Play, the Air Spy and the Perseus, but the bias T functions should be switched off. So how does it work? Well, Jim described briefly how the figure of 8 loop works, but what about this other mode called K9AY? Well, I'll let Dave describe its capabilities. So, renowned as a good DX antenna, the K9AY is another variant of the family of terminated loops, along with the pennant EWE, that's U as in sheep, but phonetically the same as U as in terminated U, and flag antennas, all of which operate in the same basic principle. The DX capability comes from the low-angle cardioid-shaped main lobe that responds to vertically polarized signals. Many descriptions of the K9AY antenna are available online, including from Gary Breed, K9AY himself. So, there are numerous examples online if you search for K9AY loop antenna. But as a starting point, I recommend reading about Gary's own development design route. As a low band fan, I was impressed with the U antenna developed by Floyd Const, WA2 WVL. Const shows us how to build a compact directional antenna, a design that quickly became popular. But when I sat down at the computer to figure out the best way to install my own U, a surprising new design emerged from my modelling experiments. Ladies and gentlemen, allow me to introduce you to the terminated loop, a concept that further shrinks the space required for a good receiving antenna without sacrificing performance. Figure 1, I'll show you in a moment, compares the real estate requirements of my 4-direction loop system to that of an equivalent U array. The new system is not only smaller, it's easier to install, needing only 1 support instead of 5. So there's his ground plan there, showing the comparison between the 4 U's and the new design that he came up with. A comparison between the two. The loop system shows that the loops need only 1/7 of the area of the U's, and they provide the same directional properties. There's the circuit of the terminated loop. It's physically and electrically quite simple, and it consists of a wire loop of any convenient shape, diamond, delta, hung from a single support and with a ground rod at the bottom. A 9-to-1 impedance matching transformer connects to one end of the loop to ground. A terminating resistor connects the other end of the loop to ground. This antenna is directional, favouring signals arriving from the feed point end, rejecting by several S points any signals arriving from the end connected to the terminating resistor R-term, or RT there, 600 ohms. To cover all directions, 2 loops using the same support are orientated to right angles to each other. Each loop provides reception from 2 directions when feed point and termination are reversed, for a total of 4 separate patterns. And there's a simple passive switching design there, the relay box there. So rather a simple affair, but just reversing the feed and the termination connections there provides the different patterns there. Now, somebody has actually produced a really upmarket version of one of these switches, and here on the right you can spot the band pass filters here, and the preamplifier here, and then the control circuitry back and front. And you can actually use this with your TX aerial. You've got different sockets obviously for the antenna to receive and TX. But even so, you still only got the 4 patterns: south, west, northwest, northeast, southeast. So not as sophisticated in terms of directionality as the Aziloop. That was quite an interesting look up. Kioro in Czechoslovakia. I don't know whether you've ever come across them before, but interesting site to look at. Let's leave the technical bits. If anybody wants to know more about achieving the directional pattern and the magnetic fields, the E and H fields and that sort of thing, we'll come back to that later if you want to at the end, but let's leave that now and just play the quiz, shall we? So pencil and paper ready. We'll have a New Year quiz, and you have to identify the call sign of an NDB on each of the following 7 audio tracks. I've given you an example of one. That will actually be the first one in the quiz, so we'll be hearing that one again. So you'll hear the call sign of the NDB 3 times. The call sign consists of 2 or 3 letters. The example you heard earlier was obviously 3 letters, and it's the alphabet in Morse code. At the end of each track, I'll ask you what the call sign is. In fact, I won't do that because we're doing it online. You can just write down. We'll run the quiz through. It won't take very long. The letters are actually a clue to the location of the beating, but I won't ask you where the location is because I'll tell you that at the end. The noise level of each recording will vary because, as well as setting the compass for best readability, I also set different modes: AM, AM narrow, LSB, and so on, to get the best readability. So, who's got pencil and paper ready? 1 to 7. What I suggest we do, for each letter, give yourself a point. Okay, so you should, with 7 questions, you should get 20 points because I'll give you a clue. One of the call signs is only 2 letters. Okay, so you'll be able to get up to 20 points. So it won't look so bad if you only get 10, for instance. Okay, right. Is anybody ready to go? Okay, here comes number 1 then. I hope you're finding that fairly clear. Let's see how you get on with number 2. Okay, number 3. Okay, you don't need to tell me that that was a difficult copy. Number 4. Getting near the end at number 5. number 6. Finally, number 7. Okay, what I suggest I do is I tell you the answers, and you, for each one, you say whether you've got 1, 2, 3 points or no points at all. Obviously, it depends whether you've done any Morse learning. Is that okay? So here we go. Shall I give you the answers and you give yourself 3 points for each call sign if it's 3 letters? So the first track was HAW, that's Hotel Alpha Whiskey, Hawarden, and that's in IO83ME. IO83ME, so not so far away. Now all of these stations use 15 or 25 watts for their signal. Number 2, WTN, Whiskey Tango November, that's Warton, also in IO83 NS, 83 NS. And these are all around 337 kilohertz. Number 3, KLY, Kilo Lima Yankee, Killiney for Dublin, that's IO63 WG. That's quite a difficult copy, I'm sorry. Number 4, Whiskey Lima, WL, Whiskey Lima, that's Barrow, Walney Island, IO84 ID. 1, 2, 3, 4, 5. Number 5, Lima Bravo Alpha, that's LBA, Lima Bravo Alpha, Leeds Bradford, IO93 EU on 403 kilohertz. And you could actually, because that was so close to the next one, you could actually hear the next one underneath. And that was 1, 2, 3, 4, 5, 6. Number 6. BHX, Bravo Hotel X-Ray from Birmingham, IO92CK. And finally, RWY, Romeo Whiskey Yankee, Isle of Man, Ronaldsway, IO74 Quebec Bravo. So, I'll just give you a moment to add up your points. What I suggest you do, because I don't want to embarrass anybody, we'll open the chat, shall we? Let's see if I can open the chat properly. So if you put your call sign and the score you've got, that would be great. In the chat there, just write your message to everyone and click return. So we're down to how is it built. So, so you can see there's my my first attempt at building the loop, rather hurriedly put together with judicious use of cable ties, nylon cord and temporary supports. The radios are linked in a mains junction box, and just lazily the radios are laid on the ground underneath and are slightly longer than the base of the loop. I left the cover off the LCU, the loop controller unit, and tested everything on the dining room table. So here we've got the 12 volt power supply, not my pride and joy I'm afraid, but you know, quite useful for testing purposes. There's the common interface unit on top of the SDR Play RSP1A, which I was using at that time, and this is the SDR Uno software, and there's the Aziloop control panel here. Now my second build was more permanent with sturdier fixings and waterproofing measures. The wires and the LCU are attached to a 14mm PVC pipe, which allows the fiberglass pole to pass through to the water-filled parasol holder on the ground. The white radials are now elevated and tensioned with kettlebells, and they are at the recommended height, so that was rather handy. The top of the pole sheltered from water ingress by a modelled orange juice bottle. Each of the loop ends are slotted through the LCU cable glands separately so that they correspond to the north, south, east, west markings on the terminal block. The final assembly is secure, and the only issue will be when spring comes, because my wife will put the washing line up and dry the linen, so that's going to be a bit difficult at the present. I'll have to do a third build with slightly reduced radials, and maybe we can get around the garden a little bit easier without tripping up. So there are many YouTube videos of users' attempts with the Aziloop, but there's one who I just played you a little brief clip there of Andy, was it, who built one with similar dimensions to my own, but he's revised it for a particular purpose. And in his second version, he's built it specifically for 80 meters. So that's what I'm going to show you now.
Here's the later layers again. Today I changed the size of the loop from the Aziloop from 14 meters now to 18 meters, 18 meters per loop. And I changed, although the feed point, the height, is now 1 meter and 30 centimeters. It's higher now, and the red and blue wires are the connections for the loop directions, north, south and east and west, with Barrow clamps, and the black one are the elevated radials, for 10 centimeters distance from the elevated radials, fixed here on this point, about 3 meters away from the center. And a common mode choke also, this one from the X wire. Oh, nice, the X wire. Yes. After good results with a small one, Aziloop, I want to test the bigger one the next days, and hopefully it's a little bit better, and I will make new videos with the results. Send the 3 and the later layers.
If you get a chance to find DL8 LAS, you've got an amazing site with all sorts of different antennas over a lot of open ground. But that's basically the sort of Aziloop example there, not the one that he's now shown us on the video, which is obviously a bit larger. Where do I get it and how much does it cost? Well, after the review in Radcom, it was only available from Quiet Radio, from the maker himself, and I paid £399 for it. So £625 at Martin Lynch, £625. So it's a considerable investment. Further information there's Quiet Radio. That's an easy one to remember. quietradio.co.uk. That's probably your first port of call if you want to know any more about it. And Martin Lynch's hamradio.co.uk. And if you look up K9YA, his tech notes are really a good read if you really are interested in this cardioid pattern loop. That controller, that rather expensive controller I showed you, is available at Ham Parts. It's built by QSO. Was it QSO.cz? QRO.cz. And all sorts of information about NDBs there. I know one of your members will probably know all that, so it's got a list of publications and further information. And the actual Radcom review was May 2024. Now I'm going to pause there. I've got more examples which you might find interesting of my listening. So I'm just pausing for any questions. So you can just speak it out, or I'll put the chat back on if you like, if you're a bit mic shy, which I don't think anybody should be. But let's just open the chat, see if there are any. Oh, I'm very pleased with the marks there that you've awarded yourselves. Well done. I have to be honest that Bolton Wireless Club didn't do as well as you guys, so well done. I think the highest I got last week at Bolton was 17.
There we are. You've got a question there from Julian online in the chat.
Yes. Okay. This is driven from a PC, but even a laptop generates significant QRM. What sort of isolation is needed between PC and controller? Well, I haven't used it on any of these particular samples, but I have got an isolation interface. So it plugs into USB and it isolates the output of the USB. So that's it's a little gadget. I know what it cost me, £30, but I dare say you could buy something similar, even cheaper now. Also, you all wrap your computer cables around ferrites and various things, don't you? I had to do that with, I was using a Mac with the IC9700 and the Yaesu FT710, and I wrapped those USB cables and the mouse cable and the keyboard cable with ferrites.
What was the point of changing load? You had that slider there where you changed the load.
Well, there'll be a sweet spot somewhere where you will achieve minimum noise. Right. On the long wire, I've got a fixed 400 ohm resistor, so obviously I can't change the load on that. But basically, it's if you like, it's a resistor on the loop. Do you remember the circuit diagram?
Yeah, actually.
Yeah, so it changes the load.
Right. I thought it might be something to do with the transmission line impedance, but presumably that's just coax, is it?
Yes, it is.
Right. Okay.
I'll just give you another example while you're dreaming up another question, Evan, which here. I was tuning around on the medium wave band again, and actually I was listening out for BBC local radio stations, many of which are closing down, and I came across 1035 kilohertz, and I was expecting the station to be identified as BBC, but I was surprised to hear that it was like a radio, its sister station called Leica Gold, and it describes itself as London's only retro-Asian music station transmitting from Ingate Place, SW8. So we'll listen to it on the long wire first of all, and then on the Aziloop, and then I'll go outside with the portable radio again. So here we are on the long wire. Now, to mitigate against propagation changes, I actually recorded the next clip on the Aziloop with the same song, so you can see how close they are in terms of timing. Not a dicky bird out of it. I've got an example of Radio Caroline, and that gives you an idea of the directionality. But let me just play this one of, this is the Polish Polski radio program, Poland, on 225 kilohertz. The first one is with the terminated U long wire and the FRG 100.
roku została ochrzczona w gruncie prawosławnym i przyjęła imię Maria. Niby dobry łowca stała się przestępcą łowędzi.
Okay, let's listen to it on the Aziloop.
Sońka była córką małżeństwa warszawskich Żydów, którzy mimo biedy zadbali o jej specjalnie ukierunkowane wykształcenie. Mówiła po rosyjsku, po polsku, francusku i po niemiecku.
Okay, this is the other time signal, the MSF signal. This comes from Anthorn RS in Cumbria. It's part of the National Physical Laboratories time signal. MSF, yeah, the rugby transmitter's call sign was MSF, where M is one of the ITU prefixes allocated to the United Kingdom, and the letters SF were allocated for no documented reason. So that's how we come to call it. But it's the NPL time signal. Again, it's derived from atomic clocks and has high accuracy and reliability for a time source for our clocks. Here it is with the Aziloop. I think I was just tuning the compass there to pick up the received signal, so you can see there was quite a good null in one position. Okay, into top band. This is a German net. So first of all on the long wire, and then we switch to the Aziloop for the next clip.
Kennen sich mit Aktien eigentlich theoretisch aus. Ja, und die Frau ist 81 und die hat eine signifikant hohe Zahl, die ist zum Aktienguru auf den Leim gegangen.
Sorry, those illustrations were inaccurately described. It's actually an 80-meter German call, and the first one was with the Aziloop and the second one was the long wire. So sorry about getting those in the wrong order. But I feel you heard the difference, didn't you? You didn't need me to tell you which one was which.
Just something. I mean, the example that you showed with those storms over the continent. So, for example, if we were doing the say the 80-meter CCs or something like that, where you just really want UK stations which are on a north-south bearing, can you sort of do it so you've got that plane, that north-south plane, so not just the one direction but two directions effectively, and null out the east and west? Can you do that?
Yes, that's how you would operate in loop mode.
Loop mode, okay, yeah.
Well, you'd be in figure of 8 then, wouldn't you?
Oh, okay, yeah, I didn't quite.
Yeah, that's loop mode. The K9AY is the single direction mode, the cardioid mode. Yeah, so generally for direction finding, you want to start off with the loop mode, so you get the nulling at right angles, and and then you just confirm the direction with the K9AY mode, the single direction mode. So it avoids any ambiguity in direction finding. The way the antenna is set out in the garden is it's exactly north, south, east, west. Okay, you understand why? Because it obviously has to be aligned to the compass.
Yeah.
So, you know, I just used a compass out in the garden to make sure they were lined up in line with the magnetic markers on the compass.
Yeah.
So physically it's running north, south, east, west.
Okay. Just a couple more questions. Can you change the sort of the sharpness of the, you know, like the max, or well, either the maximum radiation or the null? Can you sort of adjust that? And if not, how wide is it? Like the 3 dB points.
I think one of the first illustrations I gave was a virtually complete nulling at 5 degrees. So 5 degrees either side of the null point.
Right, okay.
You know, the signal came up, I would say considerably, but certainly by a few dBs, I would have said.
Yeah.
So potentially, obviously it's going to be dependent on the efficiency of your setup, you know, the grounding situation, the elevated radial situation, how high you've got it off the ground. I mean, if you go with the recommended dimensions and height off the ground, you're in a safe area. But people do experiment, like Andy DL8 LAS, his loop and radios were quite a bit more off the ground, weren't they? It depends on your own ground as well, if it's over concrete or they're over grass, things like that. Generally, although this was counteracted by one of our members last week, I thought about putting it up on the garage so it would be elevated, say, 3 meters or so off the ground, and that wasn't recommended in the manual. So I veered away from that at the moment, but although it's a possibility. But one of our members last week suggested that I would achieve good results if I multiplied the radials, so I had more radials, which would be quite interesting at garage height, wouldn't it? You know, roof height of a garage, having these radials all over the place. But the Aziloop diameter, it's not that great. It's about 4 meters or something, 3 to 4 meters. So it's possible, but I don't know quite how I'd string up 8 radials at that sort of height. It's okay if you're doing it 50 meters off, 50 centimeters off the ground. That's quite easy to achieve. So that was a very interesting comment about using more radials.
Yeah, less is better than fewer, I think. That's a general rule of thumb. Can I just ask one more thing? Just probably a silly question, really. But can it be used in sort of like reverse? Can it be used like an adcock array, where you sort of get the direction of the radiation? Or people tried to do that with it, or years ago they were used to pick up submarine signals in the Atlantic. You know, as soon as the key was put down, you could see at least a line on a cathode ray tube, which gave you at least the line of maximum. It could either be, it would give you the whole 180 degrees. You know, it could be 310 degrees and 120. You wouldn't know the difference, but there'd be some other device which would tell you the direction. But can that be used to do that? Is that the
well, the Aziloop is actually. The Aziloop is ideal for LF, and you know, we're talking. I mean, the lowest frequency I played to you is 60 kilohertz tonight, isn't it? And so you could use this on the amateur bands down there. I've actually tried tuning into 136 kilohertz, but I found there was a very strong out of band signal, which actually I managed to null out so that I could actually listen to what was on 136 kilohertz. But I didn't hear anything. Now, I'm not into LF at all. This is certainly my first exploration into that area of the band. And also the same with, is it 472 kilohertz? I had a listen on there, and You know, I can null out, you know, signals that are, you know, I don't know what they are, military or whatever. And anyway, I don't know whether I'm answering the question, but it's certainly very good at LF directionality.
Yeah, the thing is, I guess if you want to find where a signal is coming from, I mean, you could just sort of rotate it a bit. But it'd be good to sort of, and I think a lot of propagation research suffers from this, is that we sort of assume that things like signals are traveling along the grey line, but that may not be the case.
No.
And so we have, as far as I know, this sort of technique, you know, the Adcock technique hasn't really been employed. It'd be good to know if certain DX signals are coming, say, on the Great Circle path or another path automatically without sort of turning a beam or anything like that, just knowing where it's coming from.
Yeah.
But yeah, probably not really what's designed for it, I don't think. But presumably you could sort of reverse the actions and what you receive from each of those arrays, you could determine the direction.
Yeah, definitely. There are the YouTube videos which exploit some of the things you've been talking about there, using the Aziloop.
Right, okay.
Just have a listen to the long wire Radio Caroline. It's not very entertaining, is it? They returned to the medium wave band on 648 kilohertz as a legal broadcaster in 2017, and they're broadcasting from.
It's one of the estuaries, isn't it? Near Ipswich.
Yes.
Near Ipswich.
Yeah, they cover Essex and Suffolk, and. Is it Orfordness?
That's one, Orfordness.
Yeah, that's right. They extended the licence to Kent and East Sussex, and they increased the effective radiated power to 4 kilowatts. And it doesn't mean much to me, but they acquired a Harris DX25 transmitter, and they sort of rebuilt it and retuned it to their frequency, and that went into service 2021. You can hear it strongly in those areas with the signal dropping off gradually further afield. I'm just quoting here. There are good radios and special receivers that can hear us at considerable distance from our transmitter, including the Netherlands, Belgium, Northern France, and depending on local conditions. And oh, don't forget Manchester as well. Let's listen to the Aziloop. So that's a little bit more acceptable, isn't it, to listen to this? And the site that they're using actually isn't open to the public. It's quite private, virtually on an island. It's not accessible to anybody except those that work there. And the site owners have made it clear they don't want people turning up there, nosing around.
They do broadcast once a month from Manx Radio.
That's right. That would be our local,
yeah,
wouldn't it? That's the one we tune to normally, but obviously the propagation there was pretty variable, even with the strongest signal there. Just listening this afternoon to some of these stations actually on, I just got a an ICR8600 receiver, and I was just tuning around to some of these stations, and the propagation changes so quickly, doesn't it, from afternoon into evening on the medium wave.
Can you just into? I mean, you talked about people sort of raising radials off the ground and stuff like that. I mean, I guess that's for the general performance, but is that to sort of lower the radiation receive angle or increase it?
Well, the diagrams that are published by K9AY just show a ground rod down in the centre. And Dave Evans' experiments have definitely shown improvements using the elevated radials. That's what it's about. It's his own experimental work, really, that has produced these good results.
Does that change the vertical radiation lobe at all, one way or the other?
I would have thought so, yes.
Yeah, because you're not all. That's the thing. Certainly with something like close in medium wave or sort of 80 meters and stuff like that, a lot of the radiation you want is going to come from high up. You're not going to be wanting the DX. In fact, you might want to null out the DX. And yeah, I mean, I've actually got one of those Wellbrook loops. Was it 1530 or something like that? Sort of an aluminium loop for about a metre in diameter, and that's got a sort of generally good overall pattern, you know, between endless and stuff on the ground. Is that the same with the loop, your loop?
Yeah. With the Wellbrook, I've got one actually, which I could have got going. I've only just acquired it, so it would have been nice to do a comparison with that tonight, but hadn't got that far. But generally, those are operated quite close to the ground, aren't they?
Yeah, that's right.
For their best results.
Yeah, I don't think getting them high makes them much better.
That's right. Yes, and this is the case. I think they found with the Aziloop.
Yeah. Yeah. Again, it's a closed circuit, big antenna, isn't it? I think what confuses me with a lot of people is there's a difference between the big sort of the quad, you know, which are full perimeters of full wavelength, versus sort of the smaller loops. And I guess the Aziloops are a bigger version of a small loop. In terms of its size relative to the wavelengths that it's best on is quite small. And I think similarly with the ones that you can buy, you know, to put inside, you know, like I said, it's not that good. If you can get them outside, it's better. But the tiny ones, which only a foot across, I mean, they're really, really sharp, but they can get good results. You know, it's a good sort of overall radiation pattern. You're paying a lot for them from someone.
As I said at the beginning, it's a flexible antenna design, and you really need to think about which frequencies you're going to be interested in as to whether you extend the length of the loop up to. I mean, mine's 10-meter wire loop, both ways, 10 meters of wire, and if you take K9AY's example there, his was almost double that, and of course you can go smaller as well. I think where you lose out, of course, is in the higher frequency range, and I think this compromise size that I've got is directional at least to 10 megahertz.
Yeah, I mean we've used the K9AY, sorry, at the farm with the contesting, and yeah, it's pretty good. It's not as sharp as it could be, but it's a good sort of compromise. It's quick to put up, and compared to putting up a phased array, something like that, it's damn simple.
There's a comment there from Julian, if you can see it on the chat, about using an HF125 with a Wellbrook loop.
Yeah. Yes, it's a little brother of the HF225 that I was showing you on my videos, wasn't it? Nice little radio there, a very desirable little radio, and 60 meters.
Yeah.
Just
Well,
what Julian's
think about Armstrong method.
the
Very
Armstrong
convenient,
method.
isn't it?
That's
can
probably
take-
the
you
negative thing about the Wellbrooks and that is that you do have to turn them if you want to work physically.
Yeah.
But just on that, it just tricked my another sort of question is that the Wellbrook sort of markets itself as you can co-locate with an amateur transmitter, close by without overloading it, and presumably the Aziloop allows for that as well. Is it designed
Yes.
for amateur?
It does warn not to, transmit to it, obviously, and near it, but it does have a certain amount of protection from your home antenna. Yes, your long wire, whatever. So you've got no fears. There is a certain amount of protection from your transmitting aerial.
Right, excellent. Yeah. Just at that solar flare, that one that sort of caused the aurora, well, tonight actually, if you could see it. That's something else that the Aziloop could be good for. I mean, you talked about NDB beacons, but if you want to go down to the maritime beacons, 60 kilohertz and below, you can track the signal strength, and you can find out if there's a solar flare. There'll be well, depends where you are, either dip or enhancement in the propagation, which you can measure on a little trace or something like that, and you can tell when the flares have gone off. It's the old way of people used to know that before satellites and all that sort of stuff. Could measure the X-rays directly and from space, but you could do that quite easily, I think, with that Aziloop, just point in the direction the beacon that you want, and away you go.
Yeah.
Fantastic. Right. Okay. Well, I think we've exhausted the questions from Evan's point of view, and we don't seem to have anybody coming up from elsewhere. So I think it's probably...
there is an internal question there, Nigel.
Go on.
Can you see it there? Your club project to design a clone at a fraction of the cost. That's your next project. That's from Julian again.
Oh, right. Okay.
I should say give Julian 5 years to come up with a design for you. Just like Dave Evans took 5 years to come up with this design. Give him 5 years, he'll come up with something.
Anyway, thanks, Mark. That's brilliant.
Okay.
Excellent evening, and a cracking, as you say, potential project. But we'll perhaps look forward to an update on it in due course to see how you're doing. But certainly you're eking out the stations there, certainly on the medium wave side of things, which is always quite interesting. And correct me if I'm wrong, Evan, but isn't the next one talking about pirate radio stations?
It is indeed. Yeah.
Yeah, we've got something which the Aziloop can be used for, to detect all these pirate stations that potentially are still around. But there you go. Anyway, so thanks, Mark. Very much appreciate it, and thanks for an excellent evening. And I think we should all clap in the appropriate way.
Thank you.
Assume we've all got the microphones open, but there you go.
Thank you. Thank you. We managed to get the technical problem sorted.
Not a problem.
By switching to a different link, Evan. Your link worked.
Oh, there you go. Lesson learned.
That's what happened. Yes. Okay. Good night, everybody.
Yeah. Thanks, Mark.